Hello everyone, welcome to the channel. Here we have question 15 given in page number 69 of chapter 4 describing motion around us. The question is, two cars A and B start moving with constant acceleration from rest in a straight line. Car A attains a velocity of 5 meter per second in 5 seconds. Car B attains a velocity of 3 meter per second in 10 seconds. Plot the velocity time graph for both the cars in the same graph. Using the graph, calculate the displacement mentioned in the two time interval. Here the hint is given. Calculate the acceleration in both the cases and then calculate the velocities at 5 instant of time to plot the graph. So here we have car A. Car A attain a velocity. So both of the cars are starting from rest. So initial velocity is 0 meter per second. It attains a velocity of 5 meter per second in time of 5 seconds. Car B used to start with from rest. So initial velocity is 0 meter per second. Final velocity for the car B is 3 meter per second and it has taken a time of 10 seconds. We need to plot VT graph for both the cars, for car A and for car B, and using the graph we need to calculate the displacement in both the cases. So here and one more thing is that we need to calculate the velocities at 5 instant. So these are the things we need to find here in this question. So let us find out the acceleration. We know that acceleration is change in velocity v minus u upon t. So here the acceleration will be 5 minus 0 meter per second taken common upon 5 second. So it is 5 upon 5 1 meter per second square. So for car A the acceleration of the car will be 1 meter per second square. For car B it will be 3 minus 0 meter per second taken common upon 10 second. So it is 3 upon 10, that is 0.3 meter per second square. That is your acceleration for car B. Now we need to make the tabular arrangement. Let us see for car A. Here we are having velocity and here I will be writing time. Now initial velocity is 0, time is 0 here. Now we have to make sure that whatever the change in velocity I will be writing here, acceleration should be maintained as 1 meter per second square. So here it is 5. What we know that acceleration is change in velocity. Change in velocity upon time. So here we have just found for car A The acceleration is 1 meter per second square, and change in velocity we doesn't know. Time is given as 5 seconds. So 5 multiplied with 1. So time it changes. So I'm taking t. So if the time is 5 seconds, the velocity change is 5. Now if I take 10 here, so it will be 10. If I take 15 here, it will be 15. And if I take 20 time 20 second, it will be 20. So if I want to see here, the acceleration will be maintained as 1 meter per second square. So this is the table I have made. For car B, let us make the table velocity and time. So here we can just see the acceleration we have found is 0.3 meter per second square equal to velocity upon time. We need to see that time is 0, so velocity will be 0. Time is your 10 second. Time is 10 second. If I just take time as 2 second, let it be. So 2 multiplied with 0.3, it will be 0.6. If I take time as 4 second, 4 3 12, that is 1.2. If I take as 6 6 3 18, 1.8. And if I take time as 8 8 to 24, 2.4. So I have got the coordinates for of Vt, velocity and time for both the cars. Now we can just plot the thing. So here I will plot the graph, a vertical line, or horizontal line. This is x and this represent x dash. Here it is y and this represent y dash. Here it is the origin. Now this horizontal line represent time and this vertical line represent velocity. So here it is 0. We can just see 0 5 10 15 20. So up to 20 we have to go. So in what way I should go? Let it be 5, then 10, then 15, and then 20, and here it is 25. Now in velocity it is up to 20 it is going, and it is somewhat, let it be 5, 10, 15, and 20. Let us go for the car A, 0 0. So here it is 0 0. Then 5 5. Here it is 5 5. Then 10 10. Here it is 10 10. Then 15 15. Here it is 15 15. And then here it is 20 20. So I can just see that a slope is obtained in this way. So this is for car A. Now for car B, 0 0, then 2.6. So definitely 0.6. Here it is 5, 1 less than 1. So if it is less than 1, I'm just saying that it is 0.6, 0.6, 0.6 and 0.6 and 2.6. So here it is 2, here it is 0.6. So this is the first one. Then 4, 1.2. Here it is 4, here it is 4 and 1.2. So 1.2 will be somewhat here. So this is the coordinate. Next 6, 1.8 somewhat here. 6, 1.8. Next 8, 2.4. So somewhat here. 8, 2.4. So for car B, the graph will be obtained in this way. So this is for car B. Now what we need to find? We need to find displacement. Let us find the displacement for car A. So for car A, we need to find displacement for car A in 5 seconds. In 5 seconds, this is what 5 seconds represent. If I just see this triangle, we need to find out the area of this triangle. I'm just making this triangle area. Here it is. This represent 5. This represent 5. Here it is the origin. So area of triangle A B O. So it is half base. Here the base is like this distance from O to B, it is 5 second, multiply with half base into height. The height is AB and it is 5 meter per second. Second and second get cancelled. 5 5 25, 25.2, that is 12.5 meter. Now we need to find out the displacement for car B, and that displacement is to be there for 10 second. So for 10 second, where it is, this is what 10 second, we can just see one more value. If it is 10, 10 3 ja 30, that is 3.0. So 10 3, it will be somewhat here. So here also the triangle is there. We can just see it is A, it is B and it is O. Here it is 10 and here it is 3. So area of triangle is half base into height. Half base is 10 second, multiply with 3 meter per second, that is the height. Second and second get cancelled. 10 3 30, 30 upon 2 is 15 meter. So in this way we have found the displacement of car A and car B. We have come across that car A displacement is 12.5 meter in 5 seconds, and for car B displacement is 15 meter in time of 10 seconds. So that these two things we have found graphically by finding the area of triangle, where the triangle area is determined by the mathematical formula half base into height. So these triangles I have taken from the graph according to the time, and we have found the area. So in this way we have solved this question. Hopefully you will able to understand about it.